Welcome to Apache SOLR session. Today I will recap on the topics which we learned during the big data class, like what is SOLR, how easily we can configure SOLR to build a sophisticated search tool. Then we will look into how machine learning can be used to improve search relevancy. So let's get started with today's session. SOLR is an open source REST API based real time search server. It offers a rich set of features like full text search, faceted navigation, spell check, highlighting, etc. It builds a highly scalable search application. So, this picture depicts the SOLR application framework. It gives an overview of the high level workflow of the SOLR. So when data is ingested from the data source, it goes through the update handler and where the pre-processing is done and index is created. Solar uses Apache Lucene framework for indexing. When uh, when a query is sent to Solar, it goes via the request handler, which uh, which does the pre-processing, and then from the index it fetches all the relevant document, sends to the response writer, which for the given response type it returns the data. So we will look into the steps to be followed for setting up SOLR for indexing and searching. You can download SOLR from the Lucene website. After installation, traverse through the bin directory where you can find the SOLR start and stop command line scripts, and you can access the admin console using localhost colon 8983 SOLR. So first step of indexing is to create SOLR core. SOLR core is nothing but a running instance of SOLR Lucene index plus the configuration file. So to create SOLR index, we would use SOLR create minus C and the core name. So here I'm using for the session, I'm using tech, TED Talk dataset. So I've given the core name as TED Talk new. Next step is indexing data. So SOLR can ingest any format of file like CSV, JSON, XML, HTML, PDF. So there are multiple ways to add data or index data into SOLR. You can use the web interface or post tool or any client API like Java, Python, or curl command. So the picture here shows the how the documents are organized within SOLR instance. So a SOLR instance can have multiple core or n number of core, and each core can have n number of document, and each document can have n number of fields. So for uh, the TED Talk data, I have used curl command to index the data into SOLR. So the uh, curl, and next you have to give the update URL of SOLR. Here I have also used the tag separator, comma, and then you have to give the URL path of the TED file, underscore main file, and then data format. So when we create SOLR core, By default, a set of configuration files are created under the SOLR server within the core folder. So these two files are used to customize um, the index field, like how do you want to process the data and store it as a field, as well as what set of features you want to enable in SOLR. So first important file is the config/managed schema. So it is an auto-generated file and it gets updated whenever you are changing any data or there you are adding any new fields to the data. So the core configuration has the field pre-processing configuration like field type. Within field type, you can specify what kind of analyzers should be used, tokenizer and filters. So here is the example of how the field is added. So field, the name, and it is assigned to a type. Then the field type would have two set of configuration, one for the index analyzer and then for the query time analyzer. Under index analyzer, you could add the tokenizer part of like how your text should be tokenized, and you could also add multiple filters. Like here, there is a filter added for stop words. So within the stop word dot text, you can add words which you want to ignore, and those words would not be indexed. And also there are like multiple filter factories, like here we are converting all the text to a lowercase. Similarly, in the query time, you could add tokenizer and filter. And here in the query time, I think there is also a filter added for synonyms. So similarly, you can configure um, your own set of rules for tokenizer, filter, and analyzer. And next set of file is the SOLR config. It has configurations for directory, how the request for handler should or the default values for request handler, and it also has what what components you want to enable for SOLR, or what features you want to enable for SOLR, like spell checking, keyword highlighting, and it also has configuration for the response format. So let's see a quick demo. So here, to start the SOLR server, you just give SOLR start, and to update the or index the data, you would give this command. Okay, let me just open that. So here I have already created the core. So I'm just indexing the file. So now the file has indexed. So to open the SOLR web interface, just type in this localhost :8983/SOLR, and to access the core, just select core selector, uh, and then go to the query tab. Okay, so in this queue you have to give your query. So I will give like title, and I want to search for keyword life and hit execute. So this will give you all the TED Talks where title is having life. Okay, so there are around 84 documents or 84 TED Talks related to this query. Okay, I can also give a faceted search. I want to facet based on the tags. Execute it. So in the end, you would get the faceting. Faceting is nothing but the a kind of a category count. So under tags, so there are around under science topic 27 TED events are there, live 25 events are there. So it's something like a count, category count. So you can go through this Lucene URL for more examples. So few output of what we have just seen. So here I've done a search for main speaker as Ken and then faceting on that. So we have seen so far how to add data and enable basic search. Is it enough? So in any software development, there is always a notion of like, can we do better? So let's see an example here. Like a typical challenge what we face in any search application. So let's say like we have deployed our search application on SOLR and we have given to user for testing. So user comes back to us and to the developer and says like for a given query, let's say here it's SOLR, um, it even though document A has more terms matching it, but document B is more relevant as per their domain. So important challenges like how can we improve this search relevance? So how to fix it? Solar has a solution for it. Uh, so what we can Solar offers is we can do query boosting. We can add parameters like something like this QF query field, and we can also mention some weights for each field. So what it will do is something like this. So it will re-update the score and give let's say additional weightage. Let's say if word is or the search term is there in title, then your weight will be increased. And if description the solar search term is exists, then it will add certain weightage. So by giving this boosting, our score, the document score will increase automatically, and the the lower ranked document, which as per the domain is more important, will get a higher ranking. But is this a feasible or a scalable solution? So what will happen if there are like thousands of queries and hundreds of fields? So it will be a cumbersome job for to manually search for optimum weights. In this case, like we have three features, so optimum values for W1, W2, W3. So how to address this kind of a scenario? So can we do this re-ranking by finding optimal weight using machine learning? One of the popular approach is learning to rank or LTR. It uses query re-ranking approach of running two queries. First, query A returns the list of document which matches the term or given query. Then re-rank top n documents by running complex query B. So if we link it to LTR, then query B is re-rank the top n retrieved documents using the trained machine learning model. So this diagram here depicts the search or a search workflow of SOLR after inclusion of the LTR module. So user query returns, let's say user query returns uh, n set of documents. So out of which top k documents is retrieved, and this document is re-ranked using the LTR model to get the updated score, and the result page would have the updated relatively ranked document based on the re-rank score. So the here if we see here the process of running the ML algorithm to find the optimum weights, this lower process is completely offline, or it's done outside SOLR. So this particular image depicts the general approach of building ranking model. So we have Q1, Q2, Qn. Let's say Qi, where I1 to n correspond to the set of n queries used in the training data, and x of j, where j corresponds to j equal to 1 to m, are the feature vectors of retrieved m documents for query Qi, and yi here is the corresponding relevance judgment or the ground truth. So when a learning algorithm is applied to this training data, it optimizes the weight on different features to generate the optimal learning model, optimal ranking model. And then this ranking model is used uh, by the SOLA for re-ranking, and all the rank is computed, and the revised score will be more relevant and customized as per our needs. So there are three major categories or approaches by which learn to rank algorithm is done. So first one is point wise, next is pair wise, and third one is list wise approach. So at high level, point wise, pair wise, and list wise approaches of learning to rank is different only in how many documents we consider while at a time consider at a time in the loss function when we train the machine learning model. So in point-wise training, as depicted in this uh, picture, a single document is reviewed at a time. So for each document, a relevance degree or a numerical value of score is updated, and then using a scoring function, then all the documents are sorted by score, and relative final rank list is formed. So Here, all the standard regression and classification algorithm can be directly applied in the case of point-wise learning to rank approach. In pairwise approach, uh, at the time of loss function, a pair of document is reviewed. So for within a given pair of document, um, algorithm comes up with an optimal ordering for that pair, and it compares with a ground truth, and then it is done iteratively to find out the relative ordering. In the list-wise approach, um, it directly looks at the entire list of document and try to come up with the optimal ordering of it. So to give you a simple analogy, you can think it of like you're measuring height, or you're doing a height measurement for a group of students. So in point-wise approach, you are having a measuring tape. You measure each student height and then record the height in a sheet of paper, and then sort everybody by the descending and then find the order. In pairwise approach, um, it is assumed that you can assume that you don't have a tape, measuring tape. So you just use take two students out of the group. Um, Using eye judgment, you just come check you find out who's taller, and then you repeat it for the whole batch and come up with a final ordering. In the list-wise approach, you repeat the eye judgment approach for the entire group of students, and you come up with an optimal ordering. So this is the whole crux of the different approaches of learning to rank. So far we have understood what is the concept of learning to rank. So now let us look into like the other main problem of like, okay, for machine learning we need data, but how to create that data or how to generate the data. So first one is even for the data, like how will we how can we label the search results? So there are two ways. One is explicit and one is the implicit way of data labeling. So explicit data is you give the search result to, let's say, a team of experts and ask them to manually score the document. So here it is a very time consuming and costly process, but final data is of high quality. There is also one another way, the implicit data generation, where we can use user action as a quantifier for relevance, like clicks, number of views, or maybe what is the duration of time a user is spending in a page. So these parameters you can leverage and use the behavior. You can use it for labeling. So higher the clicks, more relevant the document is. Higher the view time, more relevant the document is. So important issue is like it would have it is more anonymous. Like if by mistake user clicks on some wrong link, it will be accounted as relevant. So next, how to create. We have seen like how to label the data, but how to create the features. So feature uh, is a value by which you can relate it to a document or query. to which the document is scored. Okay, so you can think it of as a, some examples are like document length, frequency of query in the header, matches with the title. So you can go through this link. This has many types of features, gives you details of like what kind of features you can configure. So high level, like few examples are uh, like field length. You have to just give this parameter in your feature store, and this will account for what is the field length of title. Field value feature. So these are like inbuilt feature classes of SOLR. So you don't have to write any code. You just plug and play kind of a code. So configure these feature classes, field value feature, then field equal to the hits. So it will create the value of hit as a feature, hit tag as a feature. Then original score feature, it will give you the original score of the document. We can also create some dynamic features using the SOLR feature um, class, where I can apply a filter query, and for field category, I want to check if it contains book. Okay, so it will generate uh, a Boolean value like yes or no. So next is we have seen how to create data. Now let's look into the training part. So training part is we are more familiar with that aspect. Like it is more similar to the ML algorithm training, which we normally do. So once these features assume like we are able to extract the feature as a CSV file in this kind of a format. So here I have used three features: is category, views, and score for this demo. And I have manually added relevance as one of the parameter as a labeled value or a target value. Okay, and so it's equal to like human expert are manually adding up labels for it, or if you have any user behavior which you can capture, that also you can do. So once that is done, then your CSV file is created. Then you can you our normal way is like of any machine learning training process. You read the CSV file, run it through the machine learning algorithm. Here I've used a Python program to do this training. And then once you do that, you will get the weights or the coefficient. That coefficient you update in the SOLR LTR model configuration file. Okay, so let's look into machine learning algorithm which I've used for this demo. So here I have used a linear model rank SVM for this LTR demo. So there are like multiple algorithm like lambda mart, lambda, rank net. These are like neural net kind of model which you can train using the SOLR feature data. So rank SVM is similar to linear classification built using SVM. So else, as we know, SVM is an algorithm which projects the data into an n-dimensional space. And in that n-dimensional space, SVM algorithm finds a hyperplane that separates the data points into relevant and non-relevant. So, so here it maximizes the distance between these two uh, areas, relevant and not relevant. So here I have built the rank SVM model using sklearn linear SVC API. And after that is done, the next step in model building is you extract the model coefficient values and get the weights. Once that is done, then you update model config file with ML model suggested feature weight. And last, you have to upload these files to SOLR. So once that is done, then your model training is also done. So far, we have understood why and what part of machine learning. Then we'll now see in practice what are the configuration file and how will we upload these features, upload the model into SOLR. So by default, LTR is disabled in SOLR. To enable LTR, first you have to update these configurations in the solar config.xml file. Um, Configuration you have to related to LTR directory, then declare the LTR query parser. Next, configuration related to the feature value cache, and finally declaration of the feature transformer. So these configuration has to be added to the solar config.xml. You can refer this link for a complete detail of what these configurations. So once the configuration is done, you can start Solar in LTR mode. So Solar start minus D Solar LTL enabled equal to true. So once that is done, next step is to run upload the feature store. So basically this is to give Solar or instruct Solar like what are the features to be generated or to be extracted from the document and query. Okay, so using the curl command, uh, I will you have to give the feature store path URL and then file path of the feature. It's a JSON file where we provide the feature store configuration. I'll show in the next slide that path, and then content of the file, content format of the file. It's a JSON file. And to extract the feature, you have to just provide this URL in the browser. It will extract. So here, for each query which you would be using to generate the data file, the training file, you have to do this. And what all features you want to extract uh, as part of your CSV file, mention that also. And also mention the feature store name. Okay. And if there are any dynamic parameter you are passing as part of the feature store, that also should be done. And here I want to, the VT is nothing but the output format and how many rows of data you want to extract in the rows parameter. Okay. So next, define feature. Define feature is the JSON file. This is the snapshot of the JSON file, feature file, which we would be uploading. We uploaded as part of this curl script. So here, first thing is the store name. So you have to give one feature store name, unique name, and then you'll give the feature name and what is the class you would be using to extract this feature. So since I'm doing a filter query, so I'll be using a Solar feature class. So here I'm using, I'm filtering the tags field by passing out the dynamic variable category. Okay. Next is one more parameter I'm using is views. So here I'm not doing any dynamic or dynamically generating the value. I'm just extracting the field value. So the field class is field value feature. And finally, I want the original score. So for extracting the original score, you'll be using the original score feature class. So once this JSON XML is JSON feature file is declared, you can upload it to SOLR using the curl. So next is uploading the model. So in the same way, we will use curl command to upload the model. So here the curl command and then path of model JSON file and URL of the model store is what we will give. And then if you want to view the uploaded model, you can just pass on this URL in the browser. So this is how your model JSON file looks like. So you have to give the feature file name, feature store name, which this model will be using, then model name and class of model. So here I'm using a linear model. So I've given a linear LTR linear model class, and along with that, I'll pass on all the features. So here is category feature I'm using views, and for views, I'm applying a min max normalizer. So I have to mention what will be the minimum value and the maximum value. And finally, original score as the last feature. So along with that, I will also provide the weights. Okay, so if I give 0, 0 and 1, that means it will generate score value without applying the revised weight. So these are the revised weights which my ML algorithm has the coefficient value which ML algorithm has given. So I'll be updating it here. Okay. So once that is done, then you just restart the server and just put on the LTR to see the revised re-ranking. You have to, in the URL, along with the query, you have to pass the re-rank query. So RQ is re-rank query parameter, and within that, you are calling the LTR function. So LTR key name should be there. Then pass on the model name, TED underscore model, and pass on if any dynamic variable or value you are assigning. So here in our case, we are passing category. And once that is done, then if you want to extract some additional fields, that you can mention it here. So if you see here, before this left hand side is before applying LTR or the query without LTR, and the right hand side is with LTR. So you could clearly see like the initially we had different set of documents, and after applying LTR, it has given more preference where is category is true. Okay, so let's look into the different. Let me just stop the server. and start the server in LTR mode. So I've already uploaded the feature store. I can maybe show you the feature store. Okay, so this is what the feature store is updated in SOLR, and to extract the feature I have to just pass on this URL for the query which I want to extract. So this is the output. So I can just copy this and save it as a Excel file, CSV file. Okay. So here I have manually saved it out. Hmm. Okay. So this is the file which I down extracted from SOLR, but still it needs some amount of fine tuning or so that I can run the machine learning model. So I have created a Python program to scrap the data, basically extract only the relevant data from thing, and then uh, once that is done, uh, read the CSV file, then we can here have to normalize the data, view data. So the same parameters which I've given in the feature store, I'm using the same here, and applying the SVM linear classifier to build a model and then get the feature weights. So once that is done, we can just see both the results. So this is without LTR. This is with LTR. So if we see after applying LTR, it has given more importance to wherever the category is matching to motivation. Okay, so all the category equal to 1 are coming up first. Okay, so with this, I want to end the tutorial session here. If you have any queries, do reach out to me. Thank you.